Hi everybody, Mrs. Pesic here. We're looking at homework help on section 3.5, problem number 21. This is a radioactive decay problem. They do tell us that the half-life for this radioactive isotope 226 radium is 1,599 years. That means it will take 1,599 years, or I should say every 1,599 years, you will have half the amount that you started with at the beginning of that time period. So just a quick recap of that absolute value idea. So if I start with, make a little table here, not that you have to do this for this problem, this is for educational purposes. If I say the year and the amount, let's say I started with, 200 grams. Well, actually, let's start with their initial amount. If I started with 10 grams, year zero, I would have 10 grams. Let me put it that way. Okay. And then 1,599 years later, I would be down to 5 grams, right? And then if I go another 1,599 years, that would be what? 3198, I'm guessing, right? 3,200 minus 2. And so then I would be down to 2.5 grams and so on. So every 1,599 years, I will lose half of what I had at the beginning of that 1,599 year period. Okay, so that kind of gives you a little overview of half-life. And so in this case, we do need to use our model here, which is y equals a times e to the negative vt. And we need that negative in there because it is an exponential decay model. So for example, if I was going to graph this, the exponential decay model, this radioactive decay, it would look something, the graph would look something like this, right? It's going to be, as time goes on, the amount of the substance, so the amount of the radioactive material is going to be going down. It never is going to reach zero. But it's just going to keep going further and further down. So we do want exponential decay, and that's why we need that negative there in our graph. Okay, so let's begin now that we've had that little overview of radioactive decay. We're using this model. They tell us that the initial quantity is 10, so I'm going to plug in 10 here, okay? And they tell us that the half-life is 1,599. So I can actually plug that number in here. And what's special about that? That tells me that in 1,599 years, I know exactly how much I'll have left. I'm going to have 5 grams left. So that means I can plug in 5 right here, because this is the amount remaining after t years. This is the initial amount here. This is obviously the number of years for t. And then b is just a constant that we are going to need to find as like step number 1. So let's try this. We are going to write 5 equals 10 times e to the opposite of b times 1,599. And that's supposed to be a 9. And so then to solve this, I'm going to divide both sides by 10. And when I do that, I am getting 1/2, or I could write as 0.5. These 10s are dividing out. I get e to the negative 1,599b. I just rearranged those two things that are being multiplied. And now to solve for something that's locked up here in an exponent, we are going to need to rewrite this in log form. So we're going to write log to the base what of what equals what. And so in this case, it's going to be log to the base e of 0.5 equaling negative 1,599b. And I can rewrite log to the base e as ln. So I get ln of 0.5 equaling negative 1,599b. And now I need to solve this. So I'm going to divide both sides by 1,599. And I'm grabbing my calculator, and I'm going to do this on my calculator. Hold up for a second. Let's see, I want to make sure. Oh, okay, hold up. One thing I forgot. Maybe you guys are like, wait, wasn't there supposed to be a negative? There was. I could almost barely not see it with this, that little, my little box is there, but that was supposed to be a negative there. So I really need to divide both sides by a negative 1,599. Don't go crazy with that negative there. So negative 1,599. So now I'm reaching for the calculator, and I am putting in a fraction template, and I want ln of 0.5, and I'm dividing by negative 1,599. I'm getting 0.000433. So I'm going to write that down. That's my B value. B is 0.000433, and I would keep all of those decimal places. And that means that I can write my model now as y equals, I know the initial amount was 10, e to the, now hold up for a second. Remember that we're using a model with a negative in it, right? So I do need to have a negative in front of that B value that we just found. So negative 0, that's supposed to be a negative, 0.000433 t. So here's the model that I'm going to use for this problem. And now, forgot what the question was. The question is, find the amount after 1,000 years. So now I can just plug in 1,000 for the t, and we'll get our amount. So I really need to do y equals 10 times e to the negative 0.000433 times this 1,000. Okay, and so let's grab the calculator to do this. I want 10 times, I'm going to use my e to the x button. I need negative 0.000433 times 1,000, and I'm getting 6.5 approximately. We can just round to the nearest tenth for our final answer with the amount remaining. So about 6.5 grams. So I would just say, I'll just type up my answer here. I would just say there will be, already 6.5. Yep, 6.5 grams remaining after 1,000 years. All right, and that's it for problem number 21. Thanks for watching.